Hi, I'm Narendra, and this is our final project for CIS 563, physically based animation. And I'm going to give a brief overview of our project, followed by the implementation details, papers followed, and then few. Okay, now coming to the problem statement, uh, it's pretty simple. How do we make a mocap character react to a dynamic? If you have to explain to somebody that like mocap files are, as everybody knows it, they are static motion files, and they don't recognize any dynamic environment or they don't react. We can basically classify the approach into 5 steps. First step will be the initial is applied onto the character, react to it. Like we react to it by simulating a particular portion of the animation with a physical, find a closest match to the physically simulated blend the initial motion to a target motion. We are trying to implement the steps 4 and 5 from the flow diagram. Most critical work is with coming up with a framework to implement this, and which the framework should have a mocap layer as well as a physics engine to provide a and some of the libraries which we used and frameworks which we used in our approach are as shown, like the Carnegie Mellon University's motion capture player and Simicon framework, which will give some details in the next slide. The main paper which we have chosen for implementing the approach is dynamic response for motion capture animation. This is a SIGGRAPH paper presented in investigating a proper base framework on top of which we can build a method and implement all the functions required. And so here are some of the investigation details. Like we have and some of the pros and cons are listed as you can see. Hybrid framework should match the skeletal structure of the CMU player with the Simicon, and it should have a mocap layer for playing the mocap files. We have divided it into 3 stages, and in stage 1, we are supposed to calculate the weighted distances between the frame windows and searching for a frame with the smallest distance from the simulation result, and integration of the physics environment with the motion player, and creating a second simulated motion using joint controllers based on the selected animation. So what we have achieved till now is like the first 2 points as highlighted, and the third point like pre-processing the database to find unique frames based on the weighted distance, and blending of the transition motion to match the selected motion clip from the stage. In this second stage, we have finished the first point highlighted as shown in the slide. And here are some of the results which we have got. We have integrated the physics engine, which is the OD engine present in Simicon player, and right now mocap player for Simicon framework is in progress. And we had to study like a huge code base of the Simicon as well as the CMU player to understand their abilities and come up with a hybrid framework. And the distance metric function is tested with the test code written, and it is implemented in CMU player. So now we have to integrate the CMU player with the Simicon framework to find out the distance metric function. This is the Simicon framework skeleton, which has a predefined mesh structure, and it is very simple in geometry as compared to the CMU player, which as you can see from the torso to the head itself, it has 6 joints in the chain. But in the Simicon framework, as you see the torso till head, there is only 1 joint. Everything is matched the Simicon skeleton to have the same structure as the CMU player skeleton. So what we have done is like to avoid the predefined meshes and all the stuff, we have a collision primitives visualization in the Simicon framing of the legs and the hand bent inside. This is because of the framework in Simicon, which uses the physics engine for and so you get this weird result. But right now we have all the 30 joints which are there in the CMU player. So we right now have all the 30 joints in the Simicon framework. So that's mostly our presentation, and hopefully we'll see a good result at the end of the project. Thank you.